Hello, everybody. My name is Eric Owens. I am the Vice President of American Distilling Institute. We are starting a series of webinars to disseminate information out into the community. And so our first webinar here is Sean Patterson with Good Libations talking about water. You know, water it's an ingredient in multiple steps and everything that we do. And yet there's a lot of variability in water. Water has a lot of different chemical components to it. So we're always trying to learn more about it and how it affects spirits. So a little news off the top. We have opened our speaker proposals for Denver for 2019. So those will close, I forget, sometime in September. So if you have an idea for a breakout session for Denver 2019, please look at those. I know they're on our e-newsletter right now. I don't know exactly. I believe it's also on distilling.com, but I don't know off the top of my head where to send you. So there's a big September is planned for us. There will be a lot of things going on. Number one is we will be opening the judging registration. At the end of September, we also have the Craft Distilling Expo. So if any of you are in London or want to go to London, and you know, they're all gin crazy out there. If you're a gin fan, gin super fan, there's really great tastings and discussions on gin. In December, we have the blending and maturation class with Nancy Fraley at Iron Root Republic. That is a fantastic class, which I'm pretty sure all participants loved last year. We're doing it again. It's a little bit more expanded than her classes around the conference. This video will be recorded, and we have our ADI video library. The conference, 2017 conference is available there. The 2018 Gin Summit is available there. And if you went to the 2018 conference, then you can also see we recorded all the breakout sessions, and those are available there. If you have any ideas for webinars that you would like to see in the future or present yourself in the future, you know, email me, Eric O, E-R-I-K-O, at distilling.com. And our next webinar will be September 12th. And look at the e-news for that. And with that, I will hand it off to Sean at Good Libations.
Thank you, Eric, and thanks to the ADI for creating an educational forum for the industry to collaborate. And welcome everybody to Hiding in Plain Sight. We really appreciate you joining us. During this meeting, we want to share how you might use water to help create your best tasting spirits. And one of the things we're going to talk about is how water might be the secret ingredient that's actually hiding in plain sight. So hopefully you'll find some keys today that might help you create your best spirits without changing anything in your distillation process. Who is Good Libations? We're a food sciences company. We have a patented approach that was developed by food science industry leaders, Doctors Devin Peterson and Samaro Kinkinadau. They are associated with the University of Minnesota, which is where we, Good Libations, actually licensed our technology, where the patents are pending. Our work is with distillers, and we identify proofing water solutions to help optimize the taste of distilled spirits. The simplest concept is we're all familiar with wine pairings, where a sommelier pairs wine with food to optimize the taste. We as proofing water solutions company, we pair water with distiller spirits to optimize the taste. And so the information that we'll be sharing today is information that we've gathered as a result of our company interest, and hopefully it'll have applications and help all of you. As we think about taste, our food scientists look at flavor from a multimodal standpoint. Of course, all of you intuitively know this. As you think about your distilled spirits, the first thing we do is we actually look at the color, but we also then smell. So the olfactory glands are involved. We think about the taste, and so certainly the taste buds that are located on our tongue are involved, and certainly all the way through that experience, the front, the middle, and the back, we get different viscosities, different tastes associated with that, and so taste is involved, but also the burn or the smoothness, and so the trigeminal nerve system gets involved as well, and it's really all of those senses combined that actually create the flavor sensation associated with a distilled spirit, and it's really coming up with the right balance of those different factors that lead to having a great tasting product, that all of those have to work in concert. And water quality can be used to impact all three of those perceptions: the smell, the taste, and the burn, and thus provide the basis to optimize the flavor of your spirit. We all recognize the importance of water in distilled spirits. Water is the most abundant ingredient in distilled spirits, and we recognize that water quality is critical to the flavor of the finished spirit. However, what many of us may not recognize is when water is added to the spirit, once the spirit is already created, new flavors can be created or destroyed during that period of time. And so with that in mind, water might be the least recognized and least utilized tool in the distiller's toolbox. Now, a lot of energy and focus is on how water actually contributes to good distilled spirits. But where most distillers, or at least where we find most distillers are spending a lot of their time and energy, is in the selection of the equipment, the selection and development of processes, the selection of the right grains, the right yeast, and the right water at the beginning of the process. And almost all the distillers that we've come in touch with have well-designed water treatment processes to condition the water, which typically includes reverse osmosis. And so there's a lot of energy at the front end of the distillation process to make sure we have the right ingredients, the right inputs, the right processes in place to create great spirits. But water, as the most abundant ingredient in a spirit, is a relatively simple compound. So it's H2O, and we all know that. And so it seems that something this simple may not be worthy of the time and energy associated with managing water. And certainly as you look at the simplicity of this compound, you have to wonder how water could actually be strategic in creating a spirit with distinctive taste. So if we think about the simplicity of how water is supposed to be, and we compare that to what actually water is, and this is just a map of the United States, we could display similar kind of demonstration of water around the world, but we see that there are tremendous variations in water. We all recognize that Kentucky and Tennessee are known for their water and their hardness of their water. New England and the Pacific Northwest actually have some softer waters. We certainly recognize that Hudson Valley has been recognized for a long time that their water has qualities that's just fantastic for making breads. And so there's tremendous regional variability associated with the hardness of waters. And so we all have to manage around that. And so the systems that are put in place by all of you are certainly worth the cost, because what you're managing to, especially 99% of the distillers we call on are using reverse osmosis, that actually takes the inconsistencies in the water and the hardness of the water that we're seeing on this map and delivering a consistent product for consistent tasting spirits. However, if you look at the composition of water, we said it's simple, but when you combine that with the map that we've just displayed, we see that water composition is actually quite complex. As the scientists break down and identify the uniqueness of characteristics of water, they typically use 6 different variables, at least 6 different variables, to evaluate and create the footprint across approximately 30 different compounds. If you think about it, there are literally billions of different possible water compositions that could exist in the planet. And so as a result of that, there's a wide range of opportunities where water, if it can contribute to the taste of the spirit, there's an almost infinite array of possibilities. So in addition, depending upon what your source of water is, if it's coming from a stream or it's exposed to the seasonality, we also have seen documentation that there are wide ranges of variability in water based upon the same water source. But if it's spring, summer, winter, fall, I mean that you see tremendous changes in that same water source depending upon the organic matter that's going into the water at that period of time. The ability to customize proofing water for flavor enhancement is actually limitless if it works. So what we want to talk about a little bit is that water can contribute to the taste of your spirit. Now, most of you know that already, and many of you have actually located your distilleries based upon having access to desirable water. I mean, certainly Colorado, if you think about the Rocky Mountains, it's known for having good water, etc. So as we look at reverse osmosis, since most of you are using reverse osmosis really didn't exist until 1969. And in 1969, there was a graduate from Dartmouth, Dean Spatz, who had started actually in his one of his freshman courses where he was challenged to clean up water. And he actually went on through his freshman project. It actually became part of his graduate program. And he actually founded the first reverse osmosis company in 1969 in Minnetonka, Minnesota, Osmonics. And sure enough, the first system was actually installed at the Mayo Clinic. So prior to 1969, reverse osmosis didn't exist. And so historically, the water sources that distillers were using were those more natural organic compounds that you'd expect to find in natural water. So what does reverse osmosis actually do? And if we think about reverse osmosis for a moment, reverse osmosis takes the minerals out and the microorganisms out of the water. And if the reverse osmosis system is working properly, it will move you to the far left-hand side of this diagram, where there would be 0 parts of dissolved solids in the water, where clearly tap water would have on average around 150 parts per million. So as you start to think about different waters that we would see around the country, you would see a much higher mineralization than what you would as a result of water that's gone through reverse osmosis. So what that basically means is that the water has been neutralized. And so what we started to focus on, and what our scientists started to focus on, is what happens to the taste of a spirit when it's going through the proofing process. So most distillers believe that the taste of a spirit, a distilled spirit, is actually set, if it's a clear spirit and doesn't get aged in barrels, they believe the taste is set once that distilling process has been completed. Or if it's a aged spirit, it goes into barrels, and most believe that the taste is set once it comes out of the barrel. And we would like to challenge you during this presentation that that assumption may not be correct. So our food scientist actually did the work that's being displayed here. And we have 4 different waters and that were used in exactly the same spirit. So we have water 1, which is the left-hand blue bars in each of the clusters. We have water 2, which is the red bar in each of the clusters, water 3, water 4. So our food scientists used 4 different waters, had 4 different levels of mineralization associated with them, and they looked at the effect of those waters in the same spirit. So I think this was a single whiskey that the only difference between the samples that were observed is the water that was being used. And you can see these bars represent different aldehydes and ketones, and so that you can see that the bars actually change depending upon what water has been used. And as we all know, that the aldehydes and the ketones become the footprint for the smell, the taste, and the burn associated with the spirit. So this was quite encouraging work from the standpoint that being able to use water during the time of proofing in the same spirit was able to develop very different footprints of aldehydes and ketones, which affect the taste. So behind the scenes, what is happening with the proofing water? So what we're showing in this diagram on the left-hand side is through the distillation process, you basically get the fatty acids, the esters, the aldehydes, and the alcohols coming out of as part of your distillation process. On the right-hand side, what you see is that in the presence of alcohol, the hexanol, which happens to be one of the aldehydes, hexanol, if you proof the distillate with RO water, which has no mineralization, the arrow favors for hexanol to stay as a hexanol. So that the hexanol could switch to a hemiacetyl. Hemiacetyls tend to be more aromatic. They also tend to be slightly sweeter. Hexanol happens to be, we've all smelled it, that grassy, wet oak kind of smell that comes from some spirits. And so it might be favorable to create, to move some of that hexanol to a hemiacetyl, as opposed to leaving it in the state as a hexanol.
So just to interrupt you for a second, Sean. So there is actual flavor differences between the hexanol and the hemiacetal, and you're saying that the mineral components of the water are what is moving that sort of chemical reaction one way or the other.
Right, and so this is, it's exactly right, Eric. So basically, in this slide shows it moving the other way. So hexanol can move into a state as being a hemiacetal if it's put in the right environment. And the RO water basically creates an environment that favors hexanol remaining hexanol. However, if you start to use hard water, and again, all water is harder than RO water, basically you start to create environments that slightly start to favor moving hexanol into a hemiacetal. As we think about the hemiacetals tend to have more aroma. They tend to have sweeter taste, and so by moving some of the hexanol and some of that grassy smell to a more aromatic state, you can change the taste of the spirit. So on the previous slides where we were showing that the aldehydes and the ketones were changing, the reason the aldehydes and the ketones were changing in the same spirit is because we were using different waters that basically changed the amount of the aldehydes and ketones that were moving into the hemiacetyl state. Did that answer your question?
Yes, thank you.
You're welcome. Thanks for the question. So if we look at it, and instead of, we've aggregated the same data, but in this slide, instead of saying it's water 1, water 2, water 3, we're now using the x-axis and we've labeled it as taste 1, taste 2, taste 3, and taste 4. Here we're showing that the water 1, water that we used to create taste 1, and the water that was used to create taste 2, out of the same spirit, you have very distinctively different footprints of the aldehydes and the ketones, knowing that the aldehydes and the ketones are what drive the aroma, taste, and smoothness associated with the spirit. Our scientists were very encouraged that we're actually using proofing water to change relatively dramatically the flavor profile of exactly the same spirit. This is kind of revolutionary because we tend not to focus on proofing water as an industry. We tend not to focus on proofing water as being a strategic element in terms of our distillation process. And we certainly don't believe typically that proofing water has the ability to modify the taste of a spirit. So this is, we believe, is revolutionary.
So you're saying that this is the 4 whiskeys and those are the 4 chemical components, but you don't necessarily, there's the sensory aspect of it. So you're not displaying any sensory data here or any sensory from sensory panels, but you are saying that you have taken these 4, this one whiskey with these 4 different waters to a sensory panel, and that there have been, the sensory panel has remarked there are 4 distinct flavors for these
right samples. So Eric, that's a great point. At this point, Good Libations, we've been in existence since 2016. The research that we've done is at this point is really on the lab side. We've done the sensory tasting panels, and we know we can taste a difference, but we're in the process right now of taking this work to the next step, where we would do similar work with a set of spirits and have expert tasting panels, independent tasting panels, then do the evaluations of those spirits. Again, it would be done in a blinded manner, that they wouldn't know that it's the same spirit, that the only difference is the proofing water. And so what we would want to be showing at that point are what we would expect to find, and what we found with our customers is that proofing water, not only does it change the levels of the aldehydes and the ketones, but the next step of documentation would be that then from a sensory standpoint, with the right appropriately credentialed panel, actually observes differences in the aroma, the taste, and the burn associated with that spirit. But that work has yet to be completed. It's in process, and that's the next place where we will be taking our efforts to develop a publication. Okay, so as we started, flavor, as our flavor scientists talk about it, flavor perceptions like music. It's really the totality of the experience, and so down at the bottom we kind of display hexanol as a tuba. There aren't many solos that are written for tubas, and certainly if your spirit is loaded disproportionately with hexanol, we would expect that spirit probably wouldn't taste that good. That grassy wet oak kind of taste would be quite prominent. So what we're showing is that proofing water can actually change the spirit's composition, the mix of hexanol to the hemiacetyls, and that it can do that across the different aldehydes and the ketones. and that we don't want the tuba to go away completely, because the tuba actually has a very distinct and good role that it plays in spirits, and just like the rest of the aldehydes and ketones. But what we're trying to do is trying to create that good mix, that great composition that actually delivers the aroma, the taste, and the smoothness that actually delights the audience and your customers.
So, and on back to the chemistry aspect of that. So the hexanol is then reacting with the ethanol to make the
hemiacetals.
Acetyls, yeah. And it's the mineral components in the water which are causing those chemical reactions to occur, or to push this chemical reaction in one direction or the other.
Yes, the water acts as a catalyst to basically create that environment that allows either to tip, and so if you think of it as kind of a toggle or a teeter-totter, you can create environments that lean left, and so keep more predominant hexanol, or you can have a water composition that would have it start to lean more prominently right, so you'd have a greater proportion of hemiacetals that would be in the spirit. And by basically achieving different tipping points, we would contend that changes the composition of the spirit, which then what we've observed, and again, we may have a bias because of the business that we're in, and that's where we need to have the independent panels, but we believe we've observed that changes the aroma, the taste, and the smoothness of the spirit. So the challenge for all distillers, if you believe that water has this kind of capability, is to find a water composition that you could use during the proofing process that might change the balance of your spirit, and it would enable it to have the optimal aroma, taste, and smoothness that you as the distiller are looking for, all as a result of using the right pairing of proofing water with the spirit to optimize the taste. So if we look at it again, what we're trying to do is to create that sensation that people just love, and we want to have the right aroma, we want to have the right taste associated with it, we want to have the right smoothness or burn associated with that, and we believe that with what we found, that proofing water actually has the opportunity to improve and modify the taste of distilled spirits after the distillation process has been complete, or for those barreled spirits after the barreling has been complete. So hiding in plain sight, the component that's exciting to us is that proofing water, if we move away from RO water as our proofing water, we believe that water has the ability to actually be an effective tool to modify the taste of distilled spirits. And conceivably, where we observe, I mean, one water is being used to proof all distilled spirits. We believe that you could actually pair each distilled spirit with a water that would optimize its taste. So you might have one water for a whiskey, you might have one water for a bourbon, you might have one water for a gin, you might have one water for your vodka. And so the whole idea of pairing waters to optimize the taste of spirits could be very, very interesting new development for the industry. We believe that this really represents a fairly radical departure from what we've observed as currently industry practices, that using neutralized reverse osmosis water to proof all spirits may not be the best way to create spirits. And so we believe that there's a tool that has been overlooked by the industry at this point. And this could be an exciting new extension of distiller capabilities that could, without changing anything in the distilling process, could actually substantially change the outcome on behalf of all the distillers. So at this point, if there are other questions, I'd be happy to answer them.
Yeah, one of the first questions to come up is hardness or mineral content the only factor? What role does pH play in the sensory analysis of the water or the finished product?
pH, in our experiences, what we use pH for is actually a surrogate for our customers to determine when they have gotten the right balance. So we create our formulations, and when they're actually deploying that strategy, we say that, you know, when you hit a pH of 5.5, that's the right amount of formulation to create the taste profile. So we don't see any direct correlation with pH, but we do use that as the practical surrogate measure to know when they've got the right amount of proofing water in the spirit.
And as
did that answer your question?
Well, back to the chemistry of it too, which I believe the different mineral compositions do affect the pH of water as well. But basically you're saying that you're not using something like acetic acid or something basic to adjust the pH of the water sort of outside of those parameters. You're just using the mineral content to do those pH adjustments or get it into the pH range that is favorable.
So to restate that, what our research has found is that if, for example, I mean, there's a lot of elements that could change the pH. If you just change the pH, what we found is that so if you got to a pH of 5.5, for example, in your spirit, that how you get there makes a tremendous difference. That if you had 6 different formulations and got them up to 5.5, that you would have different taste profiles. That 5.5 or moving to a 6 in pH will not deliver, in our experiences anyway, will not deliver the same aroma, taste, and flavor. That the nuances of the water that you use to get there makes a difference in the aroma, the taste, and the flavor. So water 1, water 2, water 3, water 4 had different chemical compositions, different mineralizations. And just like they have different levels of tipping for each of the aldehydes and ketones, each of those come up with a different aroma, taste, and smoothness, some of which are not tasty at all, some of which can be quite delightful.
There is historical precedence in cognac, for example, for how quickly you add water to the spirit, and that actually has a chemical effect on the water. Do you know of actual research, or I'm trying to figure out the question I'm trying to ask it, which is how quickly you add water affects the flavor. Do you have recommendations for adding X amount of water over X time, or yeah?
So yeah, my partner Dan Fisher comes from the pharmaceutical industry. He's actually a pharmacist, our food scientists, we've talked about this. I actually cook. I make roux and gravies and things, and all of us say yes. There is in all of our experiences, there is a limiting step, a rate limiting step that you should add slowly in terms of the proofing water. There is and that's where the art actually comes in. There is a rate at which product cannot be absorbed if it's there too quickly. And in pharmaceuticals, what will happen is a product won't go into a solution if it's added too quickly. In a gravy, it won't. You won't get the product to dissolve evenly, and all of a sudden you get lumps and have bad gravy. In food and in distilled spirits, we see the same type of thing, that it actually spirit can have limits in terms of the water that it can absorb at a time, and you'll hear different people in the industry talk about that as being a flabby spirit. So I can't tell you exactly the rate, but it has been observed in a variety of different situations that if you just pour in a lot of proofing water at a time, there is the potential for a spirit not to have enough capability to absorb that, and it will affect the taste. So our recommendation would be to be patient, go slower as opposed to faster, and you're likely to get a more consistently good output.
What recommendations do you have for people watching this webinar for moving forward? Do you recommend doing tests with RO water versus tap water, or RO water, taking their spirit, using RO water, using tap water, using Dasani or Arrowhead or some other water?
Right, and I think that's a great point. We've been out working with distillers now for over 2 years, and I would imagine most distillers listening to this are probably somewhat skeptical that proofing water has the ability to perform and have an impact like what we've just displayed. So I'd probably say that the fastest and easiest thing to do would be to go to your tap water. Or if you have bottles of Dasani, which is also a mineralized water, be playful. Take a little bit of your spirit, and instead of proofing that spirit with your RO water, keep one as a control and proof it with your RO water. Take another sample of your spirit and proof that with your tap water or your Dasani, and just see what the differences are between those two, and you might get several different waters, and that would probably be a good place to start. That doesn't take time or money, and you can start to demonstrate to yourself that this has some potential. Certainly Good Libations, if anybody would want us to develop samples for them, we develop for prospective customers first round of samples free of charge. We're looking for 1.5 liters of samples, and if you go out to our website, we would be our address is there, and so you could send us the sample, and we'd be happy to develop those free of charge if anybody would be interested in that. But I think this is one of those areas, quite honestly, Eric, that's kind of liberating. It's the water's right in front of us. We have the RO water that's coming out of the system. We have all the other sources of water we have that have some degree of mineralization associated with them. I'd say, to start off and be kind of playful with it, and start to see whether you as a distiller can observe differences in the aroma, the taste, and the smoothness associated with different spirits using different kinds of waters.
I think that's it. Thank you so much, Sean.
Great. Thanks, Eric. I appreciate it.